Inspecting the electrical aspects of a fire pump system involves a comprehensive assessment of various components and their functionality. The aim is to ensure reliable operation during emergencies. Firstly, address the power source and distribution. Verify the presence of two separate power sources, typically a utility feed and an emergency generator. This redundancy is crucial for continuous operation during power outages. Inspect the automatic transfer switch to ensure it operates correctly and is wired properly. This switch automatically transfers the load from the utility to the generator when the utility power fails. Check the battery backup system, which is essential for starting the fire pump in cases where both the utility and generator power are unavailable. Verify the battery voltage and capacity to ensure it can provide sufficient power for starting. Secondly, focus on the electrical panel and associated equipment. Inspect the main electrical panel for proper labeling, circuit protection, and grounding. Proper labeling helps identify circuits quickly during maintenance or emergencies. Adequate circuit protection, such as circuit breakers or fuses, prevents damage from overloads or short circuits. Proper grounding ensures personnel safety by providing a path for fault currents to flow to ground, minimizing the risk of electric shock. Check the fire pump controller for proper wiring and functionality. The controller is the brain of the fire pump system, managing its operation and responding to signals from the fire alarm system. Verify that all electrical connections are tight and secured. Loose connections can cause overheating, voltage drops, and potential fire hazards. Thirdly, inspect the wiring and cabling. Examine all wiring and cabling for damage, loose connections, or incorrect routing. Damaged insulation can lead to short circuits and electrical hazards. Ensure that the wiring is properly sized and protected against overcurrent. Undersized wiring can overheat and cause fires, while proper overcurrent protection devices, such as fuses or circuit breakers, protect the wiring from excessive current. Check for proper grounding of all electrical equipment. Grounding provides a low impedance path for fault currents, helping to prevent electrical shock and equipment damage. Fourthly, review the motor control and protection systems. Inspect the motor starters and associated protection devices for proper operation. Motor starters control the starting and stopping of the fire pump motor, and protection devices prevent damage from overloads, short circuits, and other faults. Verify that the motor overload relays are correctly set and calibrated. Overload relays protect the motor from overheating due to excessive current draw. Check for the presence of motor temperature sensors and over-temperature protection. These sensors monitor the motor's temperature and shut it down if it exceeds safe limits, preventing damage. Fifthly, scrutinize the alarm and control systems. Inspect the fire alarm and control system for proper functionality and communication. Fire alarm systems should be able to activate the fire pump automatically upon detection of a fire. Verify that the fire pump activation and annunciation signals are working correctly. Activation signals start the pump, while annunciation signals provide information about the pump status, such as running, stopped, or faulted. Check for the presence of a remote monitoring and control system, if applicable. Remote monitoring allows personnel to monitor the pump's status from a central location, and remote control enables them to start or stop the pump remotely. Sixthly, check the ground fault protection. Verify that the fire pump system is properly protected against ground faults. Ground fault protection devices detect and interrupt ground faults, preventing electrical shock and equipment damage. Inspect the ground fault circuit interrupter, or GFCI, for proper operation. A GFCI is a type of ground fault protection device that quickly interrupts the circuit when it detects a ground fault. Seventhly, consider electrical safety. Ensure that all electrical components are accessible for maintenance and inspection. Accessibility is essential for performing routine maintenance and troubleshooting. Follow proper electrical safety protocols, including lockout or tagout procedures. Lockout or tagout procedures prevent accidental energization of equipment during maintenance or repair. Wear appropriate personal protective equipment, or PPE, when working on electrical equipment. PPE such as gloves, safety glasses, and arc flash suits protect personnel from electrical hazards. Some additional considerations include reviewing the fire pump manufacturer's instructions and maintenance manual. These documents provide valuable information about the specific fire pump model and its maintenance requirements. Consult with an electrical engineer or qualified technician for assistance if necessary. Electrical engineers and technicians have the expertise to diagnose and repair complex electrical problems. Label and document all electrical inspections and repairs. Proper labeling and documentation help track maintenance history and ensure consistent inspections. A more detailed breakdown will involve a series of specific checks and verifications. Firstly, regarding the power supply, confirm that the fire pump has a dedicated and reliable power supply, separate from the building's general electrical system. This ensures that the pump continues to operate even if other systems fail. Verify that the voltage and frequency of the power supply match the requirements of the fire pump motor. Mismatched voltage or frequency can damage the motor. Check the size of the conductors supplying power to the fire pump to ensure they are adequate for the pump's full load current and starting current. Undersized conductors can cause voltage drops and overheating. Inspect the overcurrent protection devices, such as fuses or circuit breakers, to ensure they are properly sized and coordinated to protect the conductors and motor. Secondly, regarding the transfer switch, inspect the automatic transfer switch to ensure it is listed for fire pump service and meets the requirements of applicable standards. The transfer switch should be able to automatically transfer the power supply from the normal source to the alternate source within a specified time, typically within 10 seconds. Verify that the transfer switch is properly grounded and bonded to the building's grounding system. Check the operation of the transfer switch by simulating a power failure and observing its response. Thirdly, focusing on the fire pump controller, ensure the fire pump controller is listed for fire pump service and meets the requirements of applicable standards. Inspect the controller for proper labeling indicating the functions of each control and display. Check the controller's alarm and monitoring functions to ensure they are working correctly, including alarms for low pump pressure, motor overload, and power failure. Verify that the controller is properly grounded and bonded to the building's grounding system. Fourthly, inspect the fire pump motor. Check the motor nameplate to verify that it matches the voltage, frequency, and horsepower requirements of the fire pump system. Inspect the motor windings for signs of damage, overheating, or insulation breakdown. Measure the motor's insulation resistance to ground using a megameter to ensure it meets minimum acceptable values. Check the motor bearings for proper lubrication and signs of wear or damage. Fifthly, consider the wiring and connections. Inspect all wiring and connections associated with the fire pump system, including power supply conductors, control wiring, and grounding conductors. Ensure that all connections are tight and secure, and that wiring is properly supported and protected from physical damage. Check the insulation of all wiring to ensure it is in good condition and free from cracks, cuts, or abrasions. Verify that all wiring is properly sized and rated for the voltage and current requirements of this system. Sixthly, focus on the grounding system. Inspect the grounding system to ensure it is properly installed and maintained, and that all components are securely connected. Verify that the grounding electrode system meets the requirements of the applicable electrical codes. Check the resistance to ground of the grounding system using a ground resistance tester to ensure it is within acceptable limits. Inspect the bonding connections between all metal parts of the fire pump system, including the pump, motor, controller, and piping, to ensure they are properly bonded together. Seventhly, consider the alarm and signaling systems. Inspect the fire alarm and signaling systems associated with the fire pump to ensure they are working correctly. Verify that the fire pump is properly connected to the fire alarm system and that alarm signals are transmitted to the fire department or monitoring station. Check the operation of the remote alarm and control panel, if provided, to ensure it is functioning properly. Inspect the pressure switches and flow switches associated with the fire pump to ensure they are properly calibrated and operating correctly. Furthermore, focus on the protection devices. Inspect all protection devices associated with the fire pump system, including overcurrent protection devices, overload relays, and ground fault protection devices. Verify that the overcurrent protection devices are properly sized and coordinated to protect the conductors and motor. Check the settings of the overload relays to ensure they are appropriate for the motor's full load current. Inspect the ground fault protection devices to ensure they are functioning properly and are properly coordinated with other protection devices. And finally, document all inspections and tests. Maintain accurate records of all inspections, tests, and maintenance performed on the fire pump system. Document any deficiencies or problems that are identified and the corrective actions that are taken. Keep the records readily available for review by inspectors and other authorized personnel. Regular and thorough inspections are crucial for maintaining the reliability and safety of fire pump systems. These inspections should be performed by qualified personnel who are familiar with the applicable codes and standards. Additional points to consider during an electrical inspection of a fire pump system include: firstly, confirming the presence of a disconnecting means within sight of the fire pump controller and readily accessible. This disconnecting means allows for quick and safe isolation of the electrical supply to the fire pump during maintenance or emergencies. Secondly, checking the electrolyte level and specific gravity of the batteries in the battery backup system. Low electrolyte levels or specific gravity can indicate a problem with the batteries, reducing their ability to provide backup power. Thirdly, ensuring that all conduits and raceways are properly supported and secured to prevent damage or strain on the wiring. Improperly supported conduit can sag or break, potentially damaging the wiring inside. Fourthly, verifying that the fire pump room is adequately ventilated to prevent overheating of the electrical equipment. Overheated equipment can malfunction or fail, reducing the reliability of the fire pump system. Fifthly, checking for any signs of water damage or corrosion on the electrical equipment. Water damage and corrosion can lead to electrical shorts and other problems. Sixthly, ensuring that all unused openings in electrical enclosures are properly sealed to prevent the entry of moisture, dust, or other contaminants. Unsealed openings can allow contaminants to enter, potentially damaging the equipment. Seventhly, verifying that the fire pump system is properly labeled with appropriate warning signs and instructions. Clear labeling helps ensure the safety of personnel who may be working on or around the equipment. Eighthly, checking the operation of the jockey pump, if provided, to ensure it is maintaining the system pressure within the proper range. The jockey pump is a small pump that maintains pressure in the fire protection system, preventing the fire pump from starting unnecessarily. Ninthly, ensuring that the fire pump is tested regularly in accordance with applicable codes and standards. Regular testing helps identify any potential problems early on, allowing for timely repairs. Finally, documenting any modifications or repairs that have been made to the fire pump system. Proper documentation helps ensure that the system is maintained in accordance with the manufacturer's recommendations and applicable codes and standards. By following these guidelines and performing thorough inspections, inspectors can help ensure the reliable and safe operation of fire pump systems, protecting lives and property.